Kemigisha. Kemigisha, could you give us a word of prayer? Helena?
Lord, King of glory, thank you for the provision. Thank you for everything provided to us, friends, to find food, and for don't have it. Thank you, Lord. We pray that it won't have this person. Ask you to bless us. Remember us and understand the things for them. In the glory and the name.
Amen. Thank you, Edna. All right, straight away, we are still looking at the binomial theorem, and this should be our last part of this binomial theorem. Now, last time we ended a bit prematurely, but I pray that we move on well. Please, let's focus, and let's not go into other things, but let's pay a little more of attention here so that we learn a few things here and there. Now, I don't know if people are doing exercises. I've been checking through my Google Classroom, and very few people are handing in the bit of the work. I don't know why. So I request that now the use of this is to help you to check where the problem is in your assessment. But a couple of people are not doing so. But I hope that you're working out wherever you are in your own either group or on your own. Okay, so but I still emphasize let's try as much as we can to hand in that work so that we can try to learn and know what we are supposed to do. Okay, now we are still continuing with the binomial theorem. I hope we can be able to see the screen. Okay, just a quick reminder that those are our sponsors, and then the group that is trying to help us through these lessons. If you're not aware, especially those who are new here, we have 3 partners, and then that are trying to make sure that the whole program goes on smoothly. So literally, those who are new here, that's how the whole project is running through. So Edify, the sponsors, then the secondary school, there's Christian Schools Association, then the ICT Teachers Association, that the ones trying to help us through the studies. Now, today I want us to focus more. I'm winding up this, so we are going to do a couple of examples here and there as far as the binomial theorem is concerned. And I am sure you may be having some questions here and there. Please, you can bring them up through the different past papers so that you can we can try to work through them out. But I'm going to basically see how do we approximate? How do we, if we are given a value, maybe to a certain power, and they tell us to approximate the answer using the binomial theorem, it is what we are going to focus on mostly. Okay. All right. So we are going to still keep on. Now we are going to should be able to state the binomial theorem by the time we finish all this, and then we use it to expand the different powers to any power. That is, to any power that we have, we can expand it to any power. So we need to, what's more important is us trying to apply this binomial theorem. Okay, that is what's more important. See if we can be able to apply the binomial theorem in whatever question that we are given. Okay, so application is a key as we are going to look at this. So stating, in mathematics, stating something is not really so important, but what's more important is using it. That's what gives us, okay, what we need to do. So now we recall, if we recall in a previous class, in the previous two classes, we say that just a quick review is what we're doing. We say that when you have a number to a given power, for example, if we have a plus b to the power of n, now we can use different means to be able to come up with the result here. Now, if the powers are too large, maybe if n is equal to 2, the small powers are easy to work out. But in case you're given to a power, maybe to the power of 5 or to the power of 10, in most cases, the first method that we saw is that we can use the Pascal's triangle. We can use the Pascal's triangle to be able to come up with our results. That is the very first method that we saw. Now, the second one we said, we use that binomial expansion. And if we recall, I don't know if can someone try to help us recall the binomial expansion. If we have a plus b to the power n, sorry, okay, to the power n, and we are to use the binomial expansion. Yes, Joseph. Which one did we use in our previous class?
The formula.
Yes, please.
Yes, it is 1 plus
1 plus
nx plus n into n minus 1 x squared out of 2 combination 2
factorial, okay,
2 factorial, sorry, plus n into n minus 1 n minus 2 x cubed out of 3 factorial plus you continue
and so on. Thank you, Joseph. Now, this is the other bit that we looked at in our previous class. Okay, this is what we looked at in our previous class. So we said that in the case you possibly have a negative power, or you have a fraction power, you can easily use this. This is for n, which is either negative power or a fraction power. Okay, so that is what we looked at in our previous class. Now, this binomial theorem, in most cases, it is stated in 3 different ways that I want us to have in mind, and then we get to know how it is. Now, one of the ways is this one that we looked at. This is one of the ways that you can try to carry on an expansion, okay, that we looked at in our previous class. Now, the other way that we have is this other one here. Okay, this one is what also another one that we are going to focus on. Now, when we read books, most cases they give us different, but the bottom line, most cases we are summing up. When you look at what we have just written in a previous slide, this one of 1 plus nx plus n into n minus 1 out of 2 factorial x squared plus n into n minus 1 n minus 2 over 3 factorial x power 3, on and on. Now, what we are doing, we are summing up, okay? So in a summary, we would try to say this will be the same as the summation, okay? Now, we know that this R here are ranges of values, depending, starting from 0. Of course, when you check when you're writing the n combination R, most cases this R keeps on moving until you reach the power that you are at. So we start from 0 up to n. N is our power. Okay, then we put the combination, any combination. Now, usually the combination part, you can either write it, if I say NR, okay, or others can write it NCR, we are writing the same thing. Okay, and we saw what it means earlier on when we started by looking at the Pascal's triangle. We saw what this one indicates. We say this one is the same as n factorial out of n minus r factorial, r factorial. This is what we saw. But please, this is also a key concept that we need to have in mind as we work out our different functions. So this one is the same as this, but in most cases we saw that when you use a calculator, you type it directly in a calculator, you can get the answer directly. But if you also prefer to use this one here, if you want to calculate, especially at some point when you look at permutations and combinations, in most cases we don't use the calculator directly. We get to this formula and then we input. So literally here you may have n combination r, okay? Then a is to the power n minus r, then b the power of r. Now, if you remember I'll keep on reminding it, the other part when we started by looking at the Pascal's triangle, we said that if you have a plus b squared, this is the same as a squared plus 2ab plus b power 2. Now, what does this mean? It indicates that a is reducing, the power of a is reducing while b is increasing. Okay? And that's where we get this concept here. That the power of a is reducing by 1, n minus r, while the power of b is increasing. So that's why we do have this. So this is how it comes, this given part. Okay. So at some point we will be required. So it's just a summary. In a summary, when you are to write the binomial theorem, which is the summation from r equals to 0 up to n, we know that n is the power. Okay. Our n is the power. Okay. Then n combination r, a, n minus 1, and then b power r. So this is what we do have as our, we're also going to see how we can apply this one here when we are doing the calculations. What I want you to have is all these ones here at our fingerprints when we are working out. So these are two that we have. Now the third one that we do have, that we are going to use, is a bit still related to that. Okay, we have this as well. Now, we are saying that the expansion in the bracket can be a series meaning that we are moving from one to another. They are quite many, a series of sigma notations. Okay, the other one, this series, this is what we, this one here, up to n combination r, a, n minus r, br. So like they can be quite so many. This is a summary, but most cases when this summation removes the addition part of it. Now the binomial coefficients relate clearly to the powers of the term a to that. Now, and b is the variable x, and so in most cases the other one that we have, if we have this one is going to help us to find approximate values. This one is going to help us get approximate values. For example, we shall be asked maybe to find the approximate value of maybe 2.09 to the power of 7. And they tell you without using a calculator, get the result here. Meaning you're going to get an approximate what? An approximate value. So in such a case, we use this one here. In such a case, we come to this term, whereby we know that 1 plus x to the power of n, we say 1 plus. Do you know that all these, when you look at them, they are all closely related. We are just trying to reduce it down depending on what kind of question that we are having. That's what we are doing. So here we have n combination 1 x plus n combination 2 x squared plus n combination 3 x power 3 plus and so on and so forth. What do you mean by the sigma notation? Sigma notation is this one here. It's the one, it's a summation. Eh? This one is the sigma notation. This one here, the sigma notation is this summation. Yeah? It is the sigma. Of course, it is a Greek letter, but in our interpretation, it is like a summation. Eh? So that is the sigma notation. So the sigma notation, it summarizes the additions that you're going to have. Okay. If, for example, I want to sum up, let me give an example. If I say I would like to sum up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and I want to reach here, someone can summarize it by saying this is the same as summation from 1 up to 7. When someone writes this and another one writes this, you've done the same thing, but this one has summarized it, meaning you're going to sum up from 1 up to 7. Okay, that is what we mean. So that's the sigma notation. All right. I know. So what I want us to have is when we are getting approximate values, and we are going to look at quite an example here. When we are getting an approximate value of a given number that is possibly close to 1, most cases we utilize this given part. Okay, so these are the 3 that I want us to have in mind, but any of them can lead you to what? Can lead you to an answer. Any of them can lead you to an answer, but we are looking at how best can we utilize them. So I want us to first utilize this one here. In case we have, please take note of these brackets here. How this is for 1 plus x to the power of what? Power of n. That's what we do have. Let me give possibly an example. Let's have an example here. Find the approximation correct to 4 decimal places of 1.06 to the power 6. Okay, this is what we have, and they have told us to find out an approximation. Okay. Okay. What if I had 2 plus x to the power of n? Will I use that second instead of the first? Now, most cases, when you have such a case, I think that is something that we are talking. When we have 2 plus x to the power of n, this one you try to reduce it down. So this one in a form of 1 plus what? 1 plus x. You can reduce it this one down. So this one I can have, this can be the same as what? I can have, you pull the 2 out. When I pull 2 out, I can set 2 into 1 plus maybe a half x power n. So when you meaning you're going to solve this, okay? Then after getting it, you multiply it by this value here, quicker. So this one you have put it in a form of 1 plus what? 1 plus x to the power of n. Okay, where x now here is a half x. So that's how you're going to work it out in case you don't have that. Okay. All right, let's work out this. So you're saying, let me try to share something here. Let me share. Okay, let me get a clear blackboard here. Okay. Hope we can see clearly here. So we do have, they're saying find the approximation of, okay, let me check. Okay, I can have it here. Okay. just to make sure I have the question here, the approximation of 1.0. Stop share here. 1.01. 1.01 to the power of 6, and also 0.99 to the power of 4. Okay, so let me close this. All right, I hope we can now see clearly. So we are saying we have to find the approximation of 1.01 to the power of what? To the power of 6. This is what we have. And we are trying to utilize the all right. So where does the 2 you pulled out? But the 2 multiplies by the brackets. It multiplies by everything in the bracket. Okay? The 2 multiplies by everything in the bracket after the expansion is done. I think Pentagon X was asking that. It multiplies. So, okay, so we have this. Our role is to try to make sure that we get an approximate value of this. Okay, but we know that in our expansion of 1 plus x to the power of n, this is what we do have, is the same as, okay, 1 plus n combination r, okay, x, then plus n combination r, x squared plus n combination r, and this is x to the power of what? X to the power of 3. Okay. And okay, so let's look here. So plus on and on. This is, we are trying to see how we can try to get this one directly, okay, using the binomial theorem. Now from this point here, okay, let me Kebigisha Edna, you have a hand up.
Could you please read the question?
Hey, the question, eh?
Yeah.
The question is, let's try to, let me show you here the question. Okay. Stop there. Okay, so our question is, we are finding, see, find an approximation correct to 4 decimal places of 1.01 to the power of 6. This is where we are starting from, okay? And from here, we are utilizing this method here to find the approximation, whereby we know that 1 plus x to the power of n will be equal to 1 plus n combination 1 and so on. Then we move on. Okay. This one, we said it moves from 1, the r moves from 1 up to the power n. If the power is 6, it means it moves up to what? It moves up to 6. But in most cases, we are given up to a certain what? Up to certain numbers. We don't go directly, if we don't move up to the 6 itself or up to 10. Most cases, you can say we go up to maybe power x squared, or you go up to power x power 4, and so on and so forth. So literally, depending on what we are given. Like for here, we can, for this, we can move up to, we can basically move up to x squared, up to that point. Still, we shall get the same answer because we are approximating. We are not getting an exact value. We are getting the approximation. So we are saying that in so doing, we have this. This is what we have. Okay. Okay. Okay, so we are here. System present. Okay, just a little thing. Okay. Okay, something went wrong. Let's try to check here. Something. Okay. Okay, something went wrong somewhere, little. Let's try to see. Stop sharing. Okay, as the Joseph, your hand is up.
Yes, teacher.
Yes, Joseph.
I'm giving an idea about that question.
Oh, you're giving us an idea.
Yeah.
Yes.
That 1.01 power 6. If you want to put it in the form of 1 plus x power n, so it can also be as 1 plus 0.01.
1 plus 0.01.
Yeah, power 6. Yeah. Then we use that method to solve
Then we use the method to
solve the thing.
Okay. Thank you, Joseph. I need Kemigisha.
Yes, teacher.
Your hand is up.
No.
It is not up. Huh? Okay. Yes, Melissa.
Teacher, I have this part of one. When you say that when it's not 1, like if it's another value like 2, we pull out the 2.
Yes. If you're to use that method, yes.
Every time. Okay, then another question is these methods I'm seeing when it's a plus b power n, we use this summation for a positive integer, we use this summation method. Then in the beginning, we also used the method of Pascal's. So I would like a summary of this, when can I use the Pascal's method? When can I use the binomials for a fractional power or a negative power? And then this one that we are on. It looks to me like the same situation when I would have used binomial expansion. How do I know that I'm supposed to use binomial expansion and when I'm supposed to use expansion using this summation method, like the differentiating?
So okay, I've got your question. You want to find out when should I use this? When should I use the other one? Huh?
Yes.
Okay, noted. Another question? Yes, Emma. Emmanuel, Lloyd.
Yes, teacher. Hello.
Yes, Emmanuel.
I just wanted, like, suppose I choose one method of the 3 and I use in all solutions, in all the questions I may find.
So
Can't
what
I
if
do
you use all of them at once? I think the point is still coming to the same thing, that people want to know, when do I use this method? When do I use this one here? When do I use this, right? Now, let's look at this. Let's first solve this one here, okay? Let's first solve this, and then afterwards we shall look at when do we use each of them, each of those methods there, and at what given moment do we use them. Now, let's look at this together. As we are looking through, we are saying that the first thing we are comparing this, okay? We are comparing this to the other. Let me look at this, okay? So this is what we have this, and we are comparing it to one plus x to the power of what? Power of n. This is what we are comparing it to. Okay. So therefore, we shall say it will be 1 plus n 6 combination 1x. The x is this one here. Okay. Please take note. Your x is this one here. This is what you're looking at. Then we also have plus 6 combination 2 plus, and so on up to the 3. Someone might ask, why don't we go up to 6? We are approximating. Okay, we are approximating. We are not getting exact values. If you want to get an exact value, you'll end up going up to 6, but it's an approximation. So when you solve out this, we said when you, for this one here, punch it in your calculators. Punch this in within your calculators. 6 combination 1, you should be able to get 6. When you punch in your calculators. 6 combination 2, you should be able to get 15. 6 combination 3, you should be able to get 20. Okay? How? How do we punch in? Martha is asking, how do we put this in our calculators? Yes, Martha. Martha, can you unmute and talk to us? Yes, Martha. Unmute and talk to us.
I'm lost. I don't know how to.
You don't know how to? We lost you. Okay.
Punch the numbers on the calculator.
Punching in the numbers.
Excuse me,
on
sir.
the
numbers on the calculator.
Okay. Now we are keeping on moving back and forth. Now, those of you who cannot put this in the calculators, can I request you that you visit our YouTube channel and then you review our first lesson? We were learning how to put this in a calculator. I remember, I think Emma told us that. I think also Melissa also was instructing us. So can I request you to try to do that? Otherwise, we are going to, you check our first lesson. We learned how we can punch this into the calculator. So now, when you get this, we shall end up coming to this 1 plus 6x plus 15x squared plus 20x to the power of 3. Okay. Now, when you have this one here, what have you done? We have now tried to expand. We have done the expansion of this one here. Okay, we've done the expansion. Now, the next step is to now come to this question here, to this part here. Now, we don't substitute this one directly, no. What we do, this is what we are doing. We now write 1.01 as this one here, as 1 plus 0.01. This, we are comparing it to 1 plus x to the power of n. This is why, this is how we are, this is the comparison. This is how the comparison is coming in. So when you compare this to this one here, you realize that our previous our previous part that we have expanded will fit in. Okay. Or you can also say this 0.01 can be this written as the same as 1 out of what? 100. If you leave it like this is okay. If you put it like this, it is also fine. But why do we use this one here? It is basically to simplify your calculations. Just to simplify your calculations. But you can also leave it as 0.01. Okay? You can still leave it like that. Okay? So that is how you are trying to, you first compare. That's why if you have, for example, 2.09, okay, and this is, we want to get the approximation of this maybe to a certain power. What you do, you first put it in this form here, okay, to make sure it aligns to what we are having here. Now, we're also going to see what if it's a minus? What do we do? What if it's a minus also? This is plus, it's quite easy. So from here, we substitute for x. So we know that our x is 1 out of what? 1 out of 100. We expand. We now put it in the other one. We punch it into the other one that we have already solved. The other expression, we are punching it into this expression here. So that's why we are having 1 plus 6 times 1 out of 100. Okay? 15 times 1 out of 100 squared. 20 times 1 out of 100 to the power of 3. And that's how we are coming to this given part here. Okay? That's how we are coming to this given part. So from here, when you solve through and you total up, we shall end up coming up with this one here. This is what we shall be having. But remember, it is an approximation. Okay? I don't know if you punch in your calculator 1.01 power 6. Put it in your calculators. You should be coming something closely related to this one here. Okay? You may not get, even if it's not exact, but it's closely related to this given answer that we have. Is someone having a question here on this number? Someone having a question here? Yes, Emma.
Yes, teacher. Mine is not a question, but I was just making a request on computing, expanding those numbers in the first one. Like computing those in the calculator. Otherwise,
Which
I
one?
will do the other one.
Which one? The combinations.
Yeah, in the combination.
Okay. Combination,
I was
6 combination, 2 like that. Eh? Okay.
Yes.
This one here, 6 combination to putting it in a calculator is what you're
Yeah,
asking.
I'm just requesting there.
Okay. This is the second request I'm getting. Yes, Baluk, Arthur? Arthur? Yes, Baluk, Arthur?
I have not understood you well here behind.
Where? Where?
On just here on the statements here up.
Where?
On the first step.
This first step here.
Yes.
On the next
I was not
one.
there when I was not there when the lesson is starting, so I have not understood here
okay.
very well.
It's understandable for your case. It's understandable. Now, any other Katerega? Join Katerega. Katerega?
Teacher, I want to ask, to how many values of n should I approximate to? Okay, like if I'm given n is equal to, when that n is 12, like to how many values should I approximate to? Like now I've seen like you've ended that n is equal to
X squared. We've ended at x squared.
You ended at the 6 combinations within x cubed. Yeah? You didn't reach 6. Then what do you consider? What do you consider? Can I reach up to 5?
You're already told where to stop.
Okay.
We already told where to stop. Okay. Let me have Joy. Yes, Joy.
Yes, sir. For
Are you first showing us how to punch in a calculator 6 combination 1 for Emmanuel?
No. I was just trying to ask if we can only use this formula for this question.
Pardon?
I'm like, can we still use like binomial theorem, or we
It
can
is what
only
we
use?
are using. It is what we are using. It
I
is the
thought
same
that
thing.
methods.
It's the same thing.
Okay.
Okay.
But for this case, we use this expression.
Yes. Okay. Let me have Melissa. Melissa, can you show Emmanuel and the others how to punch this in a calculator? It seems the other people were not there in the first 2 lessons. That's why. Melissa, can you help them out?
If we have 6 combination 1, we press 6 on the calc, then shift, then the division sign. The division sign, on top of the division sign, we see n combination r. So after pressing the division sign, we press 1. So 6, then shift, then the division sign, then 1. That's 6 combination 1. Then you get the answer. If it's 6 combination 2, you say 6, shift, division sign, 2 equals 6 combination 3, 6, shift, division sign, then 3, then equals.
Ella, okay, so I hope we can get it here now. I hope we can get it here now. So we are saying 1, put this 0.99 in the form of this, 1 minus 0.1. Why are we doing so? We are trying to put it in this form of 1 plus x to the power of n. Okay? We are putting it in that given form. So when you rewrite it, you get 1 minus 0.01 to the power of what? To the power of 4. So when you carry on the expansion, we are saying take this as negative x. Okay? Take this as negative x. Don't take it as a positive. So in so doing, this will be our expansion. This will be our expansion. So finally, you do the substitution. Now, when you are substituting, we are substituting for only x. Okay, we are substituting for only x, which x is 0.01 or 1 out of 100. Or 1 out of 100. So when you do the substitution within, and then we shall be able to come up to this. Now, please do not punch all this. If we say we are getting the 0.09 to the power of 4, don't punch it in the calculator and then you put there the answer. We are literally using the theorem to be able to come up with the result. Okay, so I think when you please prove out this in your calculators to make sure that we end up with the same result here. This is what we have. Okay. Yes, Nyakecho. Nyakecho? Your hand is up?
Teacher. Excuse me, teacher.
Yes, Nyakecho.
Teacher, your audio was off, so
Okay.
I was not getting, but I would like to know why you subtracted.
Why we subtracted? Okay.
Yes.
Why you now this is what we are saying. We are putting it in a form because we want a 1 here plus x. This is what we want. We want to put it in this form. That's why the subtraction came in. Okay? Nyaket, are you there? So that's why the subtraction came in, because we want to put it in the form of 1 plus x to the power of n. That's why we are bringing in the subtraction side, to make sure that we have our 1 this side and we have an x this other side. Now, when you have 0.99, and in whatever form you're doing, please, as you're converting it out, make sure it is in this given form. That's the whole reason as to why. Because you cannot add, you can't say 1 plus 0.0001. You'll end up with 1.0901. That's what you'll end up with. So to be able to carry on that, that's when you bring in the what? The subtraction. But remember, the subtraction, it is a negative x. Okay, it is a negative x. Okay, Nyakecha, I hope it's fine.
Yes.
Okay, good. Okay, then you've understood now. So this is how you're going to keep on working out if we are given this one here. Now, finally, the other thing, there is a question that I gave you last time. It had to do with this. Huh? It had to do with the when you're dividing. Now, I say that when you're dividing, okay, I'm going to post the exercise after this. When you're dividing, for example, you have this 1 minus x out of 1 plus 2x to the power 4. You put this one here in a form 1 minus x, okay? 1 minus x into 1 plus 2x. And here we have our power as what? Negative 4. It becomes negative 4. If you look at your part of the inverse fraction at some point. So it becomes negative what? Negative 4. So when you put it in this form here, it means you're going to expand now only this. Okay? You're going to expand only this. After expanding, you multiply it by this other one, this 1 minus x. Okay. Because you cannot, don't expand again the 1 minus x. Eh? Someone might expand 1 minus x as well separately. No. So you expand this 1 plus 2x to the power of -4, okay? And we'll be able to come to this. Then afterwards, you multiply it by the 1 minus x. So at the end of it all, you'll end up with that given result. So in case you are given a fraction form, try to put it, okay? Try to put it in this given form. And after this, you can now, you try to simplify them separately, and afterwards you multiply them. That's what you're supposed to be doing in case you are given a fraction part of it. Okay. Yes, Joseph.
Teacher, excuse me.
Yes, Joseph.
You gave us an exercise which was the square root of 1 minus x over 1 plus x.
Yes.
But when after solving the first one and the second one, when I was multiplying them, the thing was so complicated. So I don't know.
Okay.
Yeah.
Yes, Joseph. Okay. Maybe that one there. Let me maybe answer that one there before we wind up. We're winding up. Now, about that one, as I'd given you earlier on, whereby we had, I think it was the root of 1, I think it was 1 plus x out of 1 minus x. Now, most of you were doing it rightly by separating the n, by separating the two. Now, when you're multiplying the two, hey, our time is up. Okay, I'm going to maybe send an explanation. I'm going to send an explanation of this. Hey, let me say our time is up. Do these negative powers affect the unknowns? Remember, the negative powers will be the n. Our powers will be the n. Okay. I'm going to send the explanation on how you can do the multiplication. I'm going to send the explanation on how you can do the multiplication of this after, if you have this the power -1/2 and then multiplying the 2. It is, and by the way, it's a very simple thing. If you, as long as you try to follow through, it is very, very simple. Okay, I'm going to send the explanation of this. I'm also going to send these notes here and the bit of the exercise. We are going to work out this. It's quite easy, I think. We are going to expand this in ascending power until x squared, and then we get an approximation of this. This is what we are going to do. Okay, this is what we are going to do. We're going to expand 1 plus x to the power of 1/2 in ascending power of x as far as x squared. Then we are going to get an approximation of the root 1 plus what? 0.8. I think that is a bit clear. I'm going to put it in the Google Classroom, so don't worry about if you've not copied it yet. In a few minutes when we end the lesson. All right, I think we could end here unless there's something that one or two people have. Yes, Penelope?
Yes, teacher, thanks for the lesson. Then, is this all with binomial theorem? Like, are we?
I'm going to do one more session for the examples. One more session for the examples. Yes. Yeah, I'm going to do one more session. And also, when do we use each of those given parts? I think that's the last part we shall be doing.
Then which other topic shall we handle after this one?
I think we shall run into differentiation. Yes.
Okay, thank you very much.
You're welcome. Okay, let's end here. I'm going to post the work in a little while, then we try to work through. I wish you a good day.